Well, thanks everybody for attending my session, Informix SQL Performance Tuning Tips. Been working with Informix for about 30 years. Run the Chicago Informix user group. I have my own company doing Informix consulting. So what we're going to talk about today is identifying problem SQL statements, new features with SQL Statement Cache, tracing options, and for SQL, options available with set explain and reading explain output with tuning examples and methods used to improve performance. This is SQL tuning is one of my pet projects. I've always found it interesting to help clients improve their performance of their system by tuning SQL. So identifying problem state SQL statements. First, you have to identify what SQL statements are the culprits in causing the performance issues. Some of the options you can use is onstat-g NTT to identify last time read and writes occurred on a session. Gather slow SQL statements from onstats. OAT, which is actually an older tool. You have Informix HQ now and other third-party tools like Server Studio. Look at how many times SQL statements have been executed using the SQL Statement Cache. Informix tracing features, SQL Trace. Review with the developers known problem areas in the application. That's one area that I think is missed a lot of times, is that even training the developers on how to write better SQL. Verify up-to-date statistics are correct. A lot of times, a lot of clients I've been to, that they haven't ran statistics or they don't have the right type of distributions. And then also review what tables and indexes have the most reads. Sometimes if you have some tables with an index with high reads, it probably means they're not efficient. There's not the correct indexes on it, or statistics ran on it. So to review number of reads on tables indexes. So use the table assist PT Prof to look at the buffer reads, page reads, and sequential scans. And here's the actual SQL statement to run that. And here's an example of some of the output. This is from one client that I had, where they had some of the tables and indexes that had a high number of buffer reads, and here you can see they went negative, meaning they scrolled through the values. So I went and looked at these indexes and tables to see what were they doing and what were the SQLs being ran on them. In evaluating that, I found some new indexes that could help with performance of that. After we added the indexes, the number of buffer reads dropped dramatically with the new indexes. So you're going to have a lot better performance. Instead of having to scan a lot of data, now you can only have to scan, say, 10% of it because you're using an index. Use the SQL Statement Cache. This helps you to see what SQLs are running and how many times those SQLs have ran. You run the onstat-g SSC to get that output. Saving even a second on a SQL statement that's executed a million times or more can make a big difference in performance. And in 14.10, there's some new features with the statement cache that I'll talk about. So here's the output of the Unstat.SG for statement cache. Here it'll give you, see in bold here, let me go back. You can see how many times a SQL statement has been ran, and by the database and then the user ID. So that's how you can kind of go through and look to see if these certain SQLs can be tuned to improve performance. Some new features that were added in 14.10 for statement cache. There's a new sysmaster table called SSCELM. Is a pseudo table that coincides with the Unstat.SG. You can, with the new statement cache, you can invalidate specific statements in the statement cache. And you can also lock query plans in the statement cache. So if you know certain queries that may change their query plans based on the criteria, locking the query plan will help you optimize those SQL statements better. So if you've noticed a sudden increase in response time from a query that's been used in the statement cache, the entry may have been dropped or deleted. You can monitor the usage of the statement cache and check for a drop or deleted entry by running the Unstat.SG SSC command. The database server drops an entry from the cache when one or more objects that the query depends on is altered, so that invalidates the data dictionary cache entry. The following operations cause a dependency check failure. So execution of any data definition language statement, such as an alter, drop, index, create index, might have altered the query plan. Also, the alteration of a table that's linked to another table of reference constraints in either direction. Execution of the update statistics for a table or column involved in a query. Renaming a column, database, or index with the rename statements. And when an entry is marked as dropped or deleted, the database server must reparse and reoptimize the statement the next time. So the statement cache entries portion, the SSC displays a flag field that indicates whether or not an entry has been dropped, deleted from the statement cache. The first entry has a flag with a value of DF, which indicates that the entry is fully cached, but is now dropped because the entry was invalidated. Second entry has the same statement text as the third entry, which indicates that it was reparsed and reoptimized. Here's an example where it shows that in the SSC output. So you can also selectively invalidate entries of your choice by setting the sysmaster CELM valid column to 0 as user Informix. The statement cache entry portion of the Unstat.SG SSC displays it at whether it's been validated or invalidated in the cache. Now some tracing in SQL. There's more than one way to find out tuning information for utilizing SQL. You can use the onConfig parameter SQL trace, the SQL admin API, and Informix HQ. So there's a couple ways to turn tracing on in Informix. The onConfig parameter SQL trace, you have a level of off, low, medium, and high. I would recommend if you do have it on, keep it at low. If you need to see some of the values in your SQL statements, then you can turn it on for high, but I only recommend doing that for a shorter amount of time because it can cause some performance segregation. Number of traces. How many traces do you want to keep in your SQL trace buffer? The size of each trace buffer in KB, and then whether you want to do it globally for all users or just a single user or multiple users. So here's an example. We're setting SQL trace low, the number of traces of 1,000, size of 2K, the more is global. So this allows me to trace the last 1,000 SQL statements of the instance. So it's a circular buffer. So after the first 1,000, it'll overwrite your initial values. And then also with Informix HQ, you can also look at SQL tracing. So to improve SQL tracing with the SQL Admin API, you can use these commands to manage the SQL tracing by databases. So you can do this dynamically. You can add a database, you can clear it, you can list it and remove. You can also suspend and resume tracing activity without deallocating the resources. With the SQL tracing, the memory that is used is taken from your virtual memory. So you want to make sure that you have enough virtual memory to hold your tracing information. Again, here's how you enable tracing through the sysadmin database by running the following command. So you say execute function, the task, set SQL tracing on, the value, the number of traces, the trace buffer size, low and global. And you can go, if you want to say, if you ran this and then you say, you know what, I want to go up to 5,000 traces, you would just change this command, just change that to 5,000 and run that and it'll change it. To validate that tracing is turned on, you run the onstat-g HIS, pipe it to more so you'll see the top information about the tracing information. And then after that, I'll give all the detail. It'll create a large file if you have a lot of traces on there. So here's an example of the onstat-g HIS output. Gives your trace level, your trace mode, your number of traces, statement ID, trace buffer size, the duration of your trace buffer. And then also it'll give you more information about the SQL statement. Here it gives you your estimated cost, number of rows, the runtime, the finish time, and the session ID for that SQL. And then it gives more information about your buffer reads, page reads, buffer writes, lock waits, lock requests, total execution times, how many times it was executed. Down here, it'll give you actual rows returned. If there's ISM error, it would give you the error number here if you had an error. Also, you can get the information on the SQL tracing through the SQL trace table in the sysmaster. I use this a lot. It's a lot quicker than kind of searching through the onstat-g HIS information. So here we're looking for queries that have a runtime of greater than 2 seconds. So just select count of from the SQL trace where SQL total time is greater than 2. So that'll give me the number of times it ran. If you want to just select star, you can then get all the information of the columns in the SQL trace information. Another useful table is a SQL trace _ ITER, which gives information in the form of iteration tree for each SQL. This allows you to identify which part of the query plan that took the most time to run. It's here in the chat with onmode-wm command. Now for SQL trace, that is, I have to look to see if you can do the WM command with the onConfig there. I'm not sure. But these are ways to use the execute function command to change it. So here you can run the following SQL statements. You get the SQLs that have the higher runtime than greater than a second. Here you're selecting the runtime and the SQL statements from the SysSQL trace table, where SQL runtime is greater than half a second. And then here's the information that it gives you. SQL ID, that's a unique ID for every SQL statement. The address, the session ID, the user ID, the statement type to select. The begin time and finish time, the actual run time, number of pages reads, buffer reads, read cache. Again, gives a lot of information, lock weights, sort memory, number of executions, total time. Here gives your actual rows, your ISAM errors. You can search through, create a SQL statement to select to see if there's any SQLs that have any error messages. And here it gives you the SQL statements. You can also save the history of the SQL trace information. Note, caution, when using this, it can use up a lot of space very quickly. I had a customer back when we first playing around with the SQL tracing, fill up a 20 gig DB space in 24 hours. So in the scheduler, there's a new task called Save SQL Trace. And the information is saved in the following tables. The SQL trace gives us this SQL statement, text information, and profile. And you have the SQL trace info and the trace iteration. I pretty much just look more at mostly at the SQL trace one. Well, here's an alternative to saving all tracing information. Create a task which saves the SQL trace information for the SQLs that have runtime of, say, greater than 10 seconds. This allows you to still trace SQL statements, but only show the really long-running ones. We don't really care about the sessions that are taking like 0.0001 seconds. We want to see the ones that are actually running longer that we can go and look to tune. So what I did is create a table to save tracing information I wanted, create a new DB space to put it in the table so it doesn't fill up an existing one and cause any effect of any other process. So here I created a table with information, created some indexes so I can get the results back quicker. And then here's the information that's needed to be inserted into the PH task table to activate the task. In my case, I was running it every minute. You want to see what your shortest time that your trace buffer size is. So if you're in your trace buffer, you look at the onstat-ghis, it'll tell you how many seconds that all the traces in there are valid for. So then here's the SQL trace information. I basically took a copy of the existing one and added putting in the runtime of here greater than 5 seconds. Informix HQ, it's a new monitoring tool replacing the OpenAdmin. Use Informix HQ to look at session information and see long SQLs, running SQLs. So here's a kind of example. There's a slow, under system reports, you have the slowest SQL statements. It'll give you the information on that along with the query tree. And here's you can go also and drill down on the each of the sessions. So it'll tell you the I/O wait time, CPU time. So options available with Set Explain. Set Explain is a very useful tool to help look at, drill down on SQL statements to see what part of the SQL is causing the slowness. So it generates a query plan without executing the SQL, which is useful in getting query plans for inserts, updates, deletes, where data is manipulated, but you don't want to change it. So that's using the optimizer directive, avoid execute. There's some explain enhancements that they added recently. You can turn on or off explain statistics through the onConfig parameter explain stat. 0 disables the query of statistics. This was the old format, like in version 7 and 10. Now you can enable the display of the query statistics, which gives you a lot more details on the query. So when this is enabled, the inclusion of the query statistics section is in the explain output is shown, and it shows the query plan estimated with the estimated number of rows and the actual number of rows returned. Here's an example of that. So you have the query statistics. Here it shows your costs, your estimated rows, the index it's using, and then down here it shows the number of rows it returned, the number of rows it produced, the estimated number of rows, the rows scanned, and then your time it took for the query. So you can also, for a session that you're out there that you want to see what the query plan is running currently, you can dynamically set an explain plan for a session by running on mode dash capital Y, the session ID, and 1 for on and 2 for off. The output is sent to a file called sqexplain.out with the session ID appended to it. And with Informix 11, there was a couple changes. Additional value 2 was added for explain without statistics for the session query plan only. Also, you can specify the file name and directory that you want the explain output to go to. It's a great feature to allow you to see the SQL statements executed as they're going on. Again, make sure that you don't keep it running for a long time because you can fill up your file system. So again, for set explain output, you have to set explain on before the statement you want to examine. You can specify a directory you want the file to go to. And then to review the explain output in Unix, usually puts it in the directory that you're running it from. On Windows, you'll usually put it into Informix dir SQ expln directory. Set explain output. So there are different sections in the output that it displays. First is a query, displays the execution query and indicates whether optimization was set to high or low. If you have any directives, it will list those out. Gives the estimated costs, which is an estimation of the amount of work for the query. Doesn't really translate into a time. It's only comparable to same queries, not others. An estimated number of rows is the estimated number of rows returned based on your system catalog table. So you need to make sure you have update statistics correct. You also then have a numbered list, so ordered in which the tables are accessed, followed by the access method, either index or sequential scans. The index keys will show the columns used as filters or indexes, and the query stats enabled by the onConfig explain stat. So here, the following slides will show some tuning examples of SQL based on following scenarios. Functions causing an index not to be used, criteria from it views causing sequential scans, using an in causing sequential scans, use of directives, use of subqueries, substrings in queries, use of functions in queries, and using a better index, so creating of a new index. So here's one where a function caused an index not to be used. So we have a select here from a view where we have a value, business unit, and doing upper the invoice ID. So when I ran this, I saw we were getting sequential scans on vendor table. And now in this view, it actually had the table, the view, when you look at it, it has the vendor table, the voucher, and when looking at it, it was doing a sequential scan on the vendor table. Well, when I took out, let me go back here a second. The one thing here is in the select statement, they were using an upper of the invoice ID. This caused the sequential scan by using the upper function. So here's again showing the detail of it. And then the way to improve that, you have two different ways you can kind of go about. This one, we added a index, added a function which converted all the characters to uppercase, and then created an index on that, which allowed you the query to run with using the index. In our case, we were able to go back again. In our case, we changed this to not use the upper, and it actually did the use the index. Now here's the criteria used to select from views causing sequential scans. So here we're doing a sequential scan on this table, CM deplete. So I'm looking at, when I went down to investigate it, one of the ways I kind of look at dissecting a query is I'll start to comment out parts of the where clause to see if that helps the query. So in this case, by commenting out the CM quantity on hand, it used the index. So then when I looked into what was going on with that, is that there was, in the view, it was doing a calculation for that CM on hand quantity, which was causing it to do the index. So what we ended up doing is that we changed it. So we changed the code. So we did the select without that part of the CM on hand quantity and did it manually in the code. In this case, we're going to be talking about using in clauses causing sequential scans. I had one customer where they were selecting for a value and checking if it was in any of these columns. And it was causing a sequential scan. And you can see down here the estimated number of rows searched down there was high. So how did I fix the issue? First, I created two new indexes on two of the columns in the where clause. I then changed the query to use or instead of an in. So here was a change that I made, and now we're using indexes for each one of those. and now your runtime is less than a second. I'm going to talk about use of directives for queries. Sometimes when you're looking to tune a SQL, no matter how you add indexes, you have to run update statistics, you just can't get the query to run the way you want to. So here in this case, we had a query that it was running a long time. So it wasn't doing a sequential scan, but it wasn't using the incorrect indexes. So here's where the filters were used for the indexes with the original query. When I added the order directive, the cost also in the estimated cost, sometimes you can't really use that because the original cost of the query was $57,000 and the new cost was higher. But by adding the order directive, we're using a better index to filter out, to return the data quicker. Now, next criteria is looking to use substrings when the best index isn't used. So here was a case where the query was doing a substring on a value and checking the input values. So again, it's not, even though it's using indexes, it may not be using the best indexes. So instead of using, go back here, instead of using the substring, sometimes when you use functions like this, it can cause the optimizer to do a sequential scan and not use indexes. So I took out that and then I changed it to use a matches. And by that, it then, here we're doing a key first and on the table. So watch out if sometimes developers will use the functions and use the dates to convert a date time field that can cause the optimizer to not use the index. This kind of gets to here again. Here's where I'm just talking about use if a function query causes specific index to not be used. In this case, they were using an extend on a date time field to get the value. Well, with using this extend, it's causing wrong index to be used. So in here, it was using index, but in the criteria here, it was actually all this criteria in this part of the filter was selecting like 80% of the data. So it wasn't using the best fields to use that and the best indexes. So how do we change that? We change it to use here. Let me go back here. Like I missed, oh, here it is right here, sorry. So we changed it to use, we'll go back there again. Instead of using the function, we changed the date timestamp to be greater than the beginning of the day and less than the end of the day. And that allowed it to use this index. And in this query, the original query was running in about 20 minutes. By making the change to this, it ran in like 2 seconds. So here's a case of using a better index. So sometimes, even though there's indexes out there, you have to look to see, is it using the best index it can use? So here it's doing a select, but it's using the purchase type code. Well, when we're looking at the query, yeah, purchase type code is cache, but the amount of data in there was like about a third of the data in the table. But if we can see here, we have a where clause that we're searching. We only want to search 3 days worth of data. So we know that we want to try to find an index or create a new index with the create TS field, because that's going to give us a better filter and return the data quicker. So after adding a new index with these fields, now the data is returned a lot quicker. So you get to really look at queries when you're trying to dissect them and trying to get better performance to see what's the best options. Here's subquery running slow. I see this many times. In fact, just a couple days ago, I had another client I was looking at, and it ran into this issue. So a lot of times you're doing a select from a table, and you're searching, in this case, where document number is in another table, and you from the rev table where the operator ID is John Smith. Well, this runs, but it's not the most efficient. There's adding one line to this, I'll show the next slide, makes a huge improvement. By taking, when you're doing the subquery, if you put it into the select in the subquery and join the field you're doing the in with, it comes back much quicker. And I see this pretty much at all clients that I've been at, that changing this makes it change dramatically. Now we're going to talk about some methods for improving SQL performance using multi-index scans, utilizing PDQ priority, and utilizing DS9 PDQ query map. With multi-index scans, if you have a query that has multiple criteria in the where clause, and you have indexes with those columns, the optimizer can utilize multiple indexes at once to improve performance of the query. So in here, client had this SQL statement with a lot of ORs in here and is performing a sequential scan on the table. Now here you can see it's taken 3 minutes or 3 seconds to run for this. That may not be a lot, but if you're running many times, it can have a detriment. Here are like the current indexes on the table. And looking at the query, all of them, all these indexes had, all these columns had indexes except this one, the one in bold. So I went ahead then and added that index on that one. And then after that, the query came back a lot quicker. See, now it's including that in there. And now finishes in, instead of 3 seconds, it finishes in 0.2 seconds. Again, a big difference. Utilizing PDQ priority. Setting PDQ priority is great for using creation of indexes to parallelize the index build, or for DSS type queries where you're scanning a lot of data with multiple fragments and you want to parallelize that scanning. So here, in case we set PDQ priority to 100, ran the SQL, and you can see here the maximum number of threads. So it's scanning 3 fragments to get the data. This onConfig parameter is, I think, one of the most performance improving ones out of any of them. The DS9 PDQ query mem. What it does is help for non-PDQ type queries. You can sort it in memory versus in temp space, so which can help with performance a lot. So in this case, I set DS9 PDQ query mem to 50,000, and this query, or here see the sort mem buff. That's where the DS9 query memory is. That's the amount of memory it's using for that. So that's how you can tell if the query is using that. And then if you increase it, you can also then increase the more, it'll show for another query to use more of the query, more of it. So with using DS9 non-PDQ query mem, you have to have your max PDQ, sorry, your PDQ you set the DS non-PDQ memory to be 25% of what your total memory is, your DS total memory is. So in this case, for one client, we increased DS total memory from 128, which is the default, to 50,000. And the query time for a specific query that we were testing with went from 2.5 seconds down to 0.25 seconds. Which was a big difference. But also on top of that, we saw that the wait on I/O from top went from 2% to 0. So if you do not have this set, I recommend you definitely set this query, this parameter. It can help your performance quite a bit on OLTP type queries. So in summary, talked about identifying problem SQL statements, new features with SQL Statement Cache, tracing in SQL, options available with set explain and read explain output, tuning examples, and methods used for improving SQL performance. Any questions?
Thanks, Jeff, for that.
No problem.
Anybody have any questions? You can just put it in the chat. Somebody says what versions?
Yeah, I'm trying to, hold on, there's some, okay, here, I just had a change there. Let me scroll up.
So I assume what versions, they're asking versions of Informix.
Versions for, this is
your,
what
your
version?
examples.
Yeah, for the guidelines to ensure that the instance is available to allocate sufficient resources. Yeah, you need to know how much virtual memory you have free. And for example, if you set your number of SQL traces to 100,000 and you have 2K, that's going to use 200 meg of memory out of your virtual session. SQL trace and statement cache, I think they both came out in 11. Statement cache, they came out, Jeff McMahon has a presentation, I think he did yesterday, on some changes to the statement cache that I kind of briefly talked about.
Anyone else have any questions for Jeff? Okay, then I'll say thank you, Jeff. We appreciate your coming to speak with us.
Well, thanks everybody for listening to my presentation. Hope it helps. And contact me if you have any questions. Thanks, Rhonda.
Oh, you're welcome, Jeff. Thanks again.
Bye.
Bye.
Bye-bye.